Good day, students. Welcome to our mathematics class for today. Our topic is solving simple equations. Our lesson objectives. By the end of the lesson, students will be able to 1. Identify an equation as an algebraic sentence involving equality. 2. Solve simple equations using the balance method. And 3. Check the solution to an equation. Our lesson materials include all our textbooks, content, introduction. An equation is an algebraic sentence with an equal sign. Examples of equations include 3y equals to 15, 16 minus f equals to 2, box plus 3 equals to 10. The letter or empty box in an equation is the unknown. You call it the unknown. The letter y, the letter f, the empty box, this in an equation is called the unknown. An algebraic open sentence can be true or false based on the value of the unknown. So the value of the unknown is very important. If the value of the unknown is not correct, it automatically makes an equation not to be true. Therefore, when solving equation, you have to be very careful to get the correct value of the unknown. Let's take some examples. Say whether the followings are true or false. 1. 25 is equal to 2.5x when x is equal to 10. 10 times the empty box is equal to 10 when 1 goes into the box. 3. 12 is equal to 12 minus x when x is equal to 12. 4. 6x is equal to 36 when x equal to 6. So here we are trying to find out if this algebraic sentence, which is equation because it's a sentence in equality, is it true or false? It's to be based on the value of the unknown. The unknown have been given in each of the questions. So let's look at the solution. 25 is equal to 2.5x when x equals to 10. Here we have been told that x is equal to 10. So what we are to do is where we find x, we put 10. And that is 2.5x equal to 5/2 times 10 because x is 10. When we divide 2 into 10 gives us 5. 5 times 5 gives us 25. So 25 is equal to 2.5x. Therefore, this value, x equals to 10, makes this equation 25 equals to 2.5x true. Example 2. 10 times box equals to 10. When the box, empty box, is equal to 1. So what it means is in this empty box, we put 1. So 10 times 1 is equal to 10. Thus, 10 times 1 equals to 10 is true when empty box is 1. Example 3. 12 is equal to 12 minus x when x equals to 12. What it means is when we see x, we put 12. So 12 minus x, which is now 12, gives us 0. However, we have been told that 12 is equal to 12 minus x. And we are asked to find if this statement is true, if x is equal to 12. We find out that 12 is not 12 here, 12 minus 0, because x is 12, is false, because x is 12. When x is equal to 12, this statement is false. However, if x is equal to 0, the statement would have been true. But our answer is that the statement is false if x is 12. Question number 4. 6x equals to 36 when x equals to 6. 6 times 6 is equal to 36. Therefore, 6x equals to 36 when x equals to 6 is a true statement. So far, students, we are looking at true and false statements depending on the value of the unknown. Recall that I said that the value of the unknown is very, very important in an equation. If the value of the unknown is not correct, it makes the equation to be a false statement. We have to be very careful and be guided by this. Okay, we move to our next subtopic, solution of an equation. Solution of an equation. The value of the solution of an equation is the value of the unknown that makes the equation true. So to solve an equation is to find the solution of the equation. When we are talking about equation now, because it is a statement of equality, it then means that value of the unknown must make the equation to be true. So in these following examples, we are going to look at the value of the unknown that makes the equation true. Examples. Solve the following equations and check your answers. 1. 3y plus 4 equals to 22. 2. 7a minus 4 equals to 3. 3. X over 2 minus 3 equals to 7. 4. 8c minus 2 equals to 6. 5. 5x minus 10 minus 3x is equal to 2x plus 20 minus 3x. 6. 15x plus 8 equals to 29 minus 6x. 7. X over 2 plus 1/4 is equal to half. 8. X over 2 minus 2 over 5 is equal to x over 3 minus 4 over 5. And 9. 3a over 4 minus 2a over 3 equals to 1/3. Solution. Number 1. 3y plus 4 equals to 22. We are going to use what is called the balance method. And in the balance method of solving equations, what we are doing is to balance the equation. Whatever you put on the left-hand side, you put the same on the right-hand side. It's like your balance. In the balance, for you to make the two sides of it to be the same place, what you put in the left, you put in the right. Anything you remove in the left, you remove in the right. And by so doing, the balance will be stable. And when it is stable, it is equal. That is what we are going to do in these examples. So in this question number 1, we have 3y plus 4 equals to 22. 3y and 4, they are unlike terms. But 4 and 22 are like terms. However, we are not collecting like and unlike terms per se. We are solving equation because there is an equality sign. This is a statement, an algebraic statement in equality. So using the balance method, for me to take plus 4 to 22 to collect them as like terms, I will subtract 4 from both sides. Subtract 4 from both sides. Remember, whatever you do to one side, you do to the other side. Subtracting 4 from both sides gives me 3y plus 4 minus 4 equals to 22 minus 4. If 4 plus 4 minus 4 is 0, so I will have 3y equal to 18, which is 22 minus 4. So divide both sides by 3. That gives us 3y over 3 equals to 18 over 3. Y equals to 6. To check, where we have y, we put 6. So 3 times 6 is 18 plus 4 equals to 22. Therefore, 3y plus 4 equals to 22 when y equals to 6 is true. Question number 2. 7a minus 4 equals to 3. Now, here we have minus 4. So to do away with minus 4, we are going to add 4 to both sides. So add 4 to both sides, giving us 7a minus 4 plus 4 equals to 3 plus 4. Minus 4 plus 4 is 0. We have 7a equal to 7. Divide both sides by 7. We have 7a over 7 equals to 7 over 7. So a is equal to 1. For us to check 7, wherever we have a, we put 1. 7 times 1 minus 4 will give us 3. Question number 3. X over 2 minus 3 is equal to 7. To remove 3 from this side, we will add 3 to both sides. Add 3 to both sides. And that gives us x over 2 minus 3 plus 3 equals to 7 plus 3, giving us x over 2 equals to 10. We want to have the unknown stand alone, so we will multiply both sides by 2. That will give us x over 2 times 2 equals to 10 times 2. Where we have x, we put 20. So 20 over 2 minus 3, giving us 10 minus 3, which is equal to 7. Therefore, x over 2 minus 3 equals to 7 is true when x equals to 20. Example 4. 8c minus 2 equals to 8. Add 2 to both sides. We have 8c minus 2 plus 2 equals to 6 plus 2. Minus 2 plus 2 is 0, giving us 8c equal to 8. We divide both sides by 8, giving us 8c over 8 is equal to 8 over 8. C equals to 1. To check, 8 times 1 minus 2 will give us 8 minus 2 equal to 6. Therefore, 8c minus 2 equal to 8 is true when c equals to 1. Example 5. 5x minus 10 minus 3x is equal to 2x plus 20 minus 3x. First, we collect like terms. So 5x minus 3x minus 10 is equal to 2x minus 3x plus 20. This will give us 2x minus 10 is equal to minus x plus 20. We are adding x and 10 to both sides. We add x and 10 to both sides. Still, we are collecting like terms, but using balance method. So we have 2x plus x minus 10 plus 10 equals to minus x plus 20 plus 10. And that gives us minus 10 plus 10 is 0. Minus x plus x is 0. So we now have 2x plus x, which is 3x, and plus 20 plus 10 gives us 30. Divide both sides by 3. Have 3x over 3 equals to 30 over 3. When you divide, you have x is equal to 10. We are asked to check. So to check, in that question, wherever we have x, we put 10. 5 times 10 minus 10 minus 3 times 10 is equal to 50 minus 10 minus 30 equals to 10. So 2x plus 20 minus 3x. 2x is 2 times 10 plus 20 minus 3 times 10, which is the value of x. 20 plus 20 minus 30. 2 times 10 is 20 plus this 20 minus 3 times 10 is minus 30, giving us 20 plus 20 is 40 minus 30, and that gives us 10. 2x plus 20 minus 3x, that's the other side of the question. So that gives us 2 times 10 plus 20 minus 3 times x, which is 10. So 2 times 10 is 20 plus 20 minus 3 times 10 is 30, giving us 20 plus 20 is 40, then minus 3 times 10, which is 30, which is equal to 10. Therefore, 5x minus 10 minus 3x is equal to 2x plus 20 minus 3x. Is a true statement when x is equal to 10. Example 6. 15x plus 8 is equal to 29 minus 6x. We are collecting like terms, but using balance method. So what do we do? To bring 6x here, we add 6x to both sides. What do we do to take 8 to this other side? We subtract 8 from both sides. So our statement will be add 6x and subtract 8 from both sides. That will give us 15x plus 6x plus 8 minus 8 is equal to 29 minus 8 minus 6x plus 6x. So minus 6x cancels plus 6x plus 8 minus 8 is 0. So continue to collect like terms. 15x plus 6x is 21x. 29 minus 8 is 21. We are dividing both sides by 21. So x will be equal to 1. To check, where we see x, we put 1. So 15 times 1 plus 8 gives us 23. 29 minus 6 times 1 also gives us 23. Therefore, 15x plus 8 is equal to 29 minus 6x is true when x is equal to 1. Students, I hope you are following. We are solving equation, finding the solution of the unknown by using balance method. And what is balance method? What you add or subtract from the left hand side, you do the same to the right hand side. When you are dividing or multiplying, you do the same to both sides. So example 7. X over 5 plus 1/4 is equal to half. So we are collecting like terms. So what do? We subtract 1/4 from both sides. So we have x over 5 plus 1/4 minus 1/4 is equal to half minus 1/4. We now have x over 5 is equal to 1/4. Here we have fractions. And to make fractions whole number, we multiply by the LCM. We multiply by the LCM. So we will multiply both sides by the LCM of 5 and 4, which is 20. We multiply both sides by 20. Recall, 20 is the LCM of 5 and 4. We want to make them whole numbers. So multiply x over 5 times 20 is equal to 1/4 times 20. 4x, 5 into 20 gives us 4. 4x is equal to 4 into 20 gives us 5. So 4x is equal to 5. We divide both sides by 4 because we are looking for the value of x and not 4x. So 4x over 4 is equal to 5 over 4. So x is equal to 1/4. To check, where we see x, we put 1/4. So 1/4 divided by 5 plus quarter is equal to half. When you do this division, 5 divide 5, we have 1/4. So plus 1/4, it will give us half. So x over 5 plus 1/4 is equal to half. It's a true statement when x is equal to 1/4. Example 8. X over 2 minus 2 over 5 is equal to x over 3 minus 4 over 5. We subtract x over 3 from both sides and add 2 over 5. When we do that, we have that x over 6 is equal to minus 2 over 5. Now, 6 and 5, the LCM, we want to make it whole number. The LCM is equal to 30. So we multiply both sides by the LCM, which is 30. X over 6 times 30 gives us 5x, minus 2 over 5 times 30 gives us minus 12. Divide both sides by 5. And we have that x is equal to minus 2 over 5. So minus 12 over 5 divided by 2 minus 2 over 5 equals to minus 12 over 5 divided by 3 minus 4 over 5. When you substitute and work it out, you will have that minus 6 minus 2 over 5 is equal to minus 4 minus 4 over 5, giving us minus 8 over 5 equals to minus 8 over 5. Therefore, x over 2 minus 2 over 5 is equal to x over 3 minus 4 over 5 is a true statement when x equal to minus 2 over 5. Example 9. 3a over 4 minus 2a over 3 equals to 1/3. That is the same thing as 3a over 4 minus 2a over 3 equal to 1/3 is 7 over 4. In this example, in the example 8, I use the fractions. But in this example, I want to clear the fractions from onset. And you do that by making them whole numbers by multiplying by their LCM, the LCM of the denominators. And the LCM of the denominators here is 12. So I am multiplying each term by the LCM. So we have 3a over 4 times 12 minus 2a over 3 times 12 is equal to 7 over 4 times 12. Cancel. 4 into 12 gives us 9a. 3 into 12, 4 gives us 8 minus 8a. 4 into 12, 3 times 7 gives us 21. So we have that a is equal to 21. Substitute a equals to 21 in the equation. 3a will now be 3 times 21 over 4 times 12 to clear the fraction, minus 2 times 21, that's 2a over 3 times 12 to clear the fractions is equal to 7 over 4 times 12. And that gives us, when you work this out, you have 189. Work this out, you have 168. 189 minus 168 is 21. Here, 4 into 12 is 3. 3 times 7 is 21. Therefore, 3a over 4 minus 2a over 3 equals to 1/3 is a true statement only when a is equal to 21. Okay, students, we've come to evaluation. All we have done in this topic is to solve the equations, finding the unknown, that is the value of the letter which makes the equation to be true. So we have, under evaluation, solve the following equations. 1, 7 plus 2c equals to 19. 6x plus 7 equals to 55. 4n minus 3 equals to 17. 17a minus 11 equals to 10a plus 3. M minus 5 over 2 equals to 3m minus 1. 3x over 10 minus 3 over 5 equals to half. Solution. 1. 7 plus 2c is equal to 19. So we are subtracting 7 from both sides to have 7 minus 7 plus 2c equals to 19 minus 7. 2c is equal to 12 because 7 minus 7 is 0. So, and 19 minus 7 is 12. We divide both sides by 2. Have 2c over 2 equals to 12 over 2, giving us that x is equal to 6. In question number 2, 6x plus 7 is equals to 55. So we are subtracting 7 from both sides. Have 6x plus 7 minus 7 equals to 55 minus 7. 7 minus 7 is 0. So 6x is equal to 55 minus 7, which is 48. We divide both sides by 6. And we have 6x over 6 equals to 48 over 6, giving us that x is equal to 8. Question number 3. 4n minus 3 equals to 17. Add 3 to both sides. We have 4n minus 3 plus 3 equals to 17 plus 3. Minus 3 plus 3 is 0. So we have 4n equals to 20. We divide both sides by 4. Have 4n over 4 equals to 20 over 4. And that gives us n equals to 5. Okay. Let's just look at this one that has fraction. M minus 5 over 2 is equal to 3m minus 1. We multiply both sides by 2. And that will give us m minus 5 equals to 2 into 3m minus 1, giving us 6m minus 2. Subtract m from both sides and add 2 to both sides. What will it be? Minus m minus 5 plus 2 equals to 6m minus m minus 2 plus 2. So m minus m cancels. We now have minus 5 plus 2 will give us minus 3. Different signs we subtract, but the sign in front of your answer is the sign in front of the bigger number. It's equal to 6m minus m is 5m minus 2 plus 2 is 0. So we divide both sides by 5, giving us minus 3 over 5 equals to 5m over 5. M is equal to minus 3 over 5. Students, as I recap, I want you to note one, that generally, unless you are asked to check, you don't bother checking, because it is assumed that your solution is correct. Remember what solution is. It is the value of the unknown. Recap 2, that you can do away with fraction, making it to become whole numbers by multiplying each term by the LCM of the denominators. For example, 10, 5, and 2. The denominators, their LCM is 10. Recap also that using balance method to solve simple equations means whatsoever you add, subtract, multiply, or divide to left hand side, you do the same to the right hand side. So finish with the evaluation and turn in your book for marking by next lesson. This brings us to the end of the lesson. Hope you enjoyed it. Thanks for being wonderful students. See you by next class.